This is question 19 from the first CSAT sample paper. In this question we're given a function with a recursive definition. We're told f of 1 equals f of 0 equals 0, and for n greater than 1, f of n is f of n minus 1 minus 1 if n is divisible by 2 or 3, and it's f of n minus 2 plus 2 otherwise. And what we're asked to work out is f of 1337, which you might recognise from earlier in the paper. So if you want to have a go at this question yourself, pause the video now. Okay, so what am I going to do first? I'm going to work out some... so start applying this to f of 1337 over here, and then we'll work out what's happening in general over here. So first of all, f of 1337, sorry. Is it divisible by 2? Definitely not. Divisible by 3? Well, let's add up the digits, say add up to 14, so no. So that means we use this rule, so we decrease by 2 to 1335, and then add 2. What's going to happen next? Still not divisible by 2, but it is divisible by 3. The digits add up to 12. So therefore we use this rule, we decrease this by 1 and decrease this by 1. So we get this. This is even, so we use the first rule again to get this. And now let's do the next few all at once. So now this is not divisible by 3, so we use the first rule, decrease this by 2, increase this by 2. And this again isn't divisible by 3, so we use that rule again to get to here. But now we get something that is divisible by 3, and when we take 1 off it we get something divisible by 2. And then the next isn't divisible by 3. If you kept going, the next wouldn't be, but after that we would get 1 divisible by 3, and then 1 divisible by 2. So we can see there's some kind of pattern happening. If we start, let's say we start with this even number, when we apply the rule we have to go to an odd number, and it's not going to be divisible by 3. And then we take off 2, that's going to be odd again, it turns out not to be divisible by 3. We take off 2 again, now it's odd again, but now it is divisible by 3. And then when we take 1 off that we get an even number, and then we go back to the start. So you can see we're always going to get this pair of divisible by 3 and then divisible by 2, because when we take 1 off we go from odd to even. And then it turns out we're getting a pair of non-divisible by 3s in the middle. So let's try and think about why that's happening. What's a good way to think about this? Well, we're interested in whether the number's divisible by 2 or 3. So it makes sense to me to think about this in terms of whether, in terms of all the multiples of 6, or if you know modular arithmetic, we're thinking mod 6. So basically think of this as some multiple of 6 plus some other number. Because within every, if we imagine going up into 6's, so say we start with 1 and go to 7 and then to 13 and then to 17, to 19, sorry, etc. Why is that useful? Well, because every time we go up by 6, we've gone up by a multiple of 2 and by a multiple of 3. So whatever pattern there is will have repeated in that range. So let's think about 1337 as a multiple of 6. It turns out to be 222 times 6 plus 5. So there's remainder 5 here. And I might write that as 5 mod 6. And now we'll think about how this changes when we apply the rules. If we apply, because this is 5 mod 6, it's not divisible by 3. It would have to be 3 or 0 mod 6 to be divisible by 3. So then we apply the first rule. If we decrease it by 2, it also decreases by 2 mod 6, so it decreases to 3 mod 6. Then we have to, because this ends in 3, it's divisible by 3. So it's a multiple of 6 plus 3, so that's divisible by 3. So that means we apply the second rule, get 2 mod 6, and that's going to be even, so we apply the second rule again, get 1 mod 6. Now this isn't divisible by 3, and it's odd, because it doesn't end in 0 or 3. So that means we apply the first rule, and then, well, we go to -1, but mod 6, that's the same as 5. So it's going to be some multiple of 6 plus 5. And then we end up back at the start. So you can see this pattern is going to repeat. So I've got this repeating cycle. I do 1, 2, 3, 4 different operations, and then I get back to the start again. So what happens to this number, the number inside the function, as this is going on, is decreased from 5 to 5 mod 6, so it's decreased by 6, and that makes sense because it's decreasing by 2, then 1, then 1, then 2. So, for instance, at this step, we've decreased it to 1, 3, 3, 1. What's happening to this number here, the number we're adding outside the function? Well, let's think about what rule we're using at each step. We do +2 here, -1, -1, and then +2. So overall, let's come to +2. So for each of these cycles of 4 operations, we are increasing this number by 2. So going from here to here is 1 cycle. And we're decreasing the number inside by 6. So that makes sense because we're going from 1335 to 1329, for instance. That's 1 cycle. So if we start with the number inside is x and the number, sorry, it should be a plus rather than an equals. So f of x plus y, then we're reducing x by 6 and we're increasing y by 2 for each of these cycles, and then we start again. So because this is quite a large number, obviously we don't want to go all the way down, but we can imagine it as 222 lots of these cycles, because each one reduces it by 6. And then we're going to have to figure out what happens at the end. So here I've written, once we do all these cycles, we're going to reduce this by as many factors of 6 as possible. So it's going to be reduced to 5, because it was 222 times 6 plus 5. So this is the remainder that's left over. And then for each cycle we're increasing outside by 2, so we should get plus 444. And now we, so if we just look up here, for instance, this has been reduced by 6, we've got plus 2 outside, so this is like the end of the first cycle. Bear in mind, the cycle I wrote above, you could start at any point, but we're doing it in 6s from here, so we end up at f of 5. Plus 2 times 222, so that's plus this. And since we can't complete a whole cycle before we get to f of 1, let's just work out what happens to this from this point on. So this isn't divisible by 3 or 2, so we use the first rule. So we get f of 3 and then add 2 to this to become 446. This is divisible by 3, so we reduce this and this by 1. This is divisible by 2, so we reduce this and this by 1. So we get this, and f of 1 we were told at the start is 0. And therefore our final answer is just this part, which is 444.